Hello, this is a video to go over simplifying cube roots, the lesson that we learned in class after simplifying radicals. So last class we did square roots, so just looking at groups of 2. When we're simplifying cube roots, instead of looking for perfect squares, we're going to be looking for perfect cubes or groups of 3, if you want to think of it that way. So the first thing when you're looking at this would be an example of, they would say simplify this. We would know that it's a cube root because of the index of 3. So make sure that when you make your factor tree, still it's going to be kind of the same process, but we're looking for perfect cubes, so we need groups of 3. That way we know it's not square root, versus if it was missing, that would just be 4, so it would be the square root of 2. So for this problem, we're still going to start out simplifying cube roots the same way we do simplifying square roots. We're going to make our factors, get our prime factors for this. The square root of 16, the cube root of 16, and the prime factors for 16 are, we have 4 2's. So we're just going to rewrite 16 as a product of its prime factors, so there are 4 2's in this problem. But instead of looking and circling groups of 2, that's what I was saying for the fourth time, I feel like we're looking for groups of 3. So this number here is really 8. And this cube root of 8 is 2. So this simplifies to 2. We keep this cube root symbol with the index of 3. And it would just simplify to that. So it's really not much different than what we were doing last class, but just kind of, again, looking for those groups of 3's. So we're going to do a couple more examples. And like I said, these were the examples that we did in class. So the other example we did was the cube root of 40. We did the 2 times the cube root of 432. And then the cube root of negative 875. So for 40, we're going to start the same way. 2 and 20, 2 and 10, 2 and 5. So we have 3 2's and 1 5. Rewriting all those underneath the radical. And then circling, we have one group of 2's, or the cube root of 8, which is 2, times the cube root of 5. So 432, the thing about cube roots is it gets to be, some of the numbers get kind of large. So when you're making your factor tree, just be mindful that sometimes you use large numbers. So let's see, 432, so I'm going to kind of scooch down this way. 432 would be 2 and 216. 216 is actually a perfect square. We'll just keep on dividing it by 2. 2 and 54, 6 and 9, 3, 3, 3, 2. It's kind of, you can see it can be kind of like, oh, you can't even see it all. Sometimes it kind of crams, there's a lot of factors. So then we have 2. And let's see, we have 1, 2, 3, 4 2's. And then 1, 2, 3 3's. So the way you can check that, just to make sure that it's right, is if you just type in all of your ends, 2 times 2 times 2 times 2 times 3 times 3. See, and it looks like we probably missed somebody. 1, 2, 3, 4. Yeah, it's still 144. Oh, there's 3 3's. That's why you check it. There we go. So there's your clear example. I missed one of the 3's because I crammed it on the bottom of the paper. So once you get them all, you circle groups of 3. I'm so glad I checked that. That would not have been good. And anything coming out, this is all multiplication here, so we're going to do 2 times the cube root of 8, which is 2. A 3 is also coming out, that would be the cube root of 27. And we have left underneath the 2. 2 times 2 is 4, times 2 is 3 is 12. You can always check these two. This expression here should be equivalent to this expression here. So this is unsimplified, this is simplified. With negative numbers, when you are doing the cube root, the negative has to come out. So when I go to make my factor tree, I'm just going to do a factor tree for regular 875. So 5 and 175. All these numbers, anything that ends in 5 is divisible by 5. So 5 and 35, 5 and 7. So your factor tree is going to be 3. And the way you can kind of think of it is whatever you have a group of 3 of, you can just make all of those numbers negative. So negative 5 times negative 5 times negative 5 times 7. Because when we're simplifying this, we want the negative to come out as well. You can kind of put it anywhere you want. You could have 1 negative, you could have 3 negatives, you could have these 3 numbers negative, but because we want them all to be the same, we're going to put the negative on what's coming out. So I'm going to put it right there on that group of 5s. This would be the cube root of negative 125, which is negative 5. So it would be negative 5 times the cube root of 7, since that's what's left over. Okay. And we will do one monomial, so with some variables. I'm actually going to turn to the back of the next page. So if this was your problem here, oops, at the top, okay, 3a, the cube root of 8, a to the 4th, b to the 2nd. If you know your perfect cubes, 8 is actually a perfect cube, so that's just 2. But if I make a factor tree for 8, I'm just going to get 3 2's. So 3a on the outside, and then, again, we could just simplify that, but I'll just expand it just to show you. And then 4a's and 2b's. So we are looking at groups of 3. This is going to come out, and that's going to come out. And I think everything else is going to stay. So underneath the cube root, I'm still going to have a v squared. I'm going to bring down the 3a. Out comes a 2, out comes an a. So then we can go ahead and put these together. 3a and 2a is 6a squared times the cube root of ab squared.